The function f has domain 0 to infinity and defined by f of x equals 1 minus 2 all over 3x squared plus 2. Show that f dashed is always positive. Write down the range of f. Find an expression for the inverse of the function f and state the domain and range of f to the minus 1. So let's have a look at this here then. So the first thing to do is show that f dashed is always positive. So f dashed x then, let's differentiate. The constant goes to 0. Now here we've got something 2x to the minus 1 basically in form, haven't we? It's a simple power to the minus 1, but it's a function of a function. It's something to the minus 1. So we use the function of a function rule. So the power comes down to be with the 2. Minus 1 is there basically in our mind's eye. That comes to be with the minus 2 to make 2 over the something 1 less power, which is minus 2, so that will be a squared then, won't it? Multiplied by the something differentiated, which is 6x. So it's equal to 12x then, over 3x squared plus 2 squared, and we can see that that's positive since x is positive. So x is positive, the top numerator is positive, of course. This is always positive anyway. So the whole fraction is a strictly positive number, isn't it, for any x positive. So that's done there. Part B. Write down the range of f. Well, basically, the range of f then, the derivative is always positive. So if it's got a domain 0 to infinity and the derivative is always positive, it's always going to continue to increase in value. So the smallest value of f will be at basically close to 0. So if we put 0 in here, we'll see that we'll get 0, and this will be 2. 2 over 2 is 1. 1 minus 1 is 0. So we get 0. Okay, so we get 0. So let me just write that down correctly now. Range is 0, and then it increases, doesn't it? Because f dashed is positive. So it increases. So if we put in, say, 1,000 here, we get 1,000 squared. And that will be 3 lots of 1,000 squared plus 2, which is a huge number. So it's a huge positive number here when x is large positive. 2 over a large positive is very, very small. So it's 1 take away a very, very small number. So it's going to tend towards 1, but never reach 1. So it goes up to 1, doesn't it? But doesn't touch it. So there's our range then, just by looking at the property of f dash being positive and the values at either end of this domain. Part C, find an expression for the inverse function and state its domain and range. So a bit of algebra is involved now then. So we've got y equals 1 minus 2 over 3 x squared plus 2. So I'm going to move things around now. I'm going to move this over the left and flip its sign. And then I'm going to move the y over to be with the 1. Okay, now I'm going to move this object here up to times on the other side. I'm going to read it from right to left again. So that object is there, moved up to there, and the 2 over 1 minus y. We've got that. And then we'll move the 2 across, won't we? So we've got 3x squared there is equal to 2. 2 over 1 minus y minus 2, and then divide by 3. So that will give us x squared equals 2 over 3. Now there's a 2 common, so I'm going to take that outside a bracket and put the 3 alongside it, and I've got 1 over 1 minus y minus 1 basically. So that tells us then, so let's square root both sides. So we've got x is equal to the square root of 2/3. Now this fraction here, if you think about it, this is a 1 minus y over 1 minus y, which is a bit difficult to work out. I'll just write it as that for the moment. And I'm going to write 1 minus y. I'm going to write my minus 1 as minus 1 minus y over 1 minus y. So I can combine the fraction here. So let's just do that then, just to make things a bit easier then. So x equals, it's the square root of 2/3, and it will be 1 over 1 minus y is common now, so there's a 1 minus y here. On the top you've got 1, take away 1 when you expand the bracket, and then a minus times a minus is a plus y. So that's what we've got. So our inverse function, we can read it off now when we flip the symbols. Here's our inverse function, then we'll equal and change the y to an x, isn't it? Of x over 1 minus x. So there's our inverse function. We need to specify its domain and range. So let's do that now. Now the domain of this function will be the range of the previous function, and the range of the previous function was minus 1, 1. The range of this function, the inverse, will be the domain of the previous function, which was 0 to infinity, wasn't it? So there's our domain and range. Just one little thing, when we square rooted, we didn't put a negative, simply because implicit in the question is the fact that we're dealing with x values that are only greater than 0. So the restriction allowed us not to even write down plus or minus when we square rooted, we just take the positive square root value.